Hello, and welcome to the Thinking Elixir podcast, where we cover the news of the community and learn from each other. My name is Mark Erickson.
And I'm David Bernheisel.
Let's jump into the news. First up, there's a new CVE for Erlang, which is a zip traversal. So this is a CVE 2025-4748. We have a link to it. This is the first CVE released under the new CNA program that the EEF has. So CNA is a CVE Numbering Authority. So this is their first time to really go through the whole process. So let's first talk about what is this vulnerability and what do I need to do about it? So this is a zip traversal. So what that typically means is when you include multiple sets of files in a zip, you can have relative paths for some of those files. And if you go like ... up to a parent directory and up many parent directories or something like that, you can cause a zipped file to be extracted onto maybe a system file, right? Something that's supposed to be way outside of the scope of where you are. That's what a zip traversal can usually mean. And there's different specifics that might play in here. So what's interesting is the OTP, Erlang, the Beam, has zip abilities built into it. So this is regarding what's already built in. Just to cover it, it's a 4.8 severity out of 10. And so that's considered medium. And the description is improper limitation of a path name to a restricted directory, which is the path traversal part. We have a link to the CVE that's on cna.erlf.org. So it has this new CNA site that's being used, and it has workarounds listed and references and more information about that.
The remedial, though, is there is a workaround. So if you're on a affected version, there's a different function that you can use that is not affected by the issue, and or just upgrade. Upgrade to the latest patch versions of OTP. They go back a couple versions. So if you're on an older OTP, that's okay. You don't have to go up to the latest major version. They've got security patches on some of the older ones as well. That's probably the easiest thing to do, and you ought to do it anyway. So just upgrade.
Yeah, looking at it, they describe the workaround as getting a list of all the files in the zip archive and verify that none contain absolute paths before extracting the archive to disk. So this isn't using the relative paths to get there. It's saying maybe it started off with an absolute like root level path.
Yeah.
Yes, very interesting.
Workaround as in like fix it yourself.
Yeah. If you can't upgrade for some reason, yes, then there is a way to protect yourself still. And when I saw this, I thought, this is the first time they're getting to act as a CNA. This is like, it's cool. And so from the outside, I don't have no insight to how this actually went down and what happened internally. But from the outside, this was a success, right? This was being done, handled properly and released. And I just kind of wondered, I wonder if they held back on this release just so they'd have something so they could do it as their first act of a CNA. But I doubt that's true.
And this isn't the only CVE they've published now. There is another one with Ash Phoenix as well. You'll find it on the CNA site. So if you just go to the list of issued CVEs, you'll see it. So Ash users out there, wasn't planning on talking about this, but might as well. So Ash users out there, if you're using Ash Authentication Phoenix, there is a missing session revocation on logout. And so you can just upgrade to at least version 2.10, and that'll be taken care of in that package.
And that one was just released today as of recording.
Yeah. So pretty cool. And a lovely site too. It actually looks readable. A lot of these things look like mailing lists from the 1990s, right? But this one's got a little style, so at least you can peruse all of the issues with style.
Yeah, it's clean. And clean. I will say on the list of the CVEs, they have a little link at the bottom where you can get a JSON representation of those CVEs if you wanted to do something more automated.
Oh, I wonder if they have an MCP server. All right. Well, hey, moving on. Phoenix MacroComponents. We talked about that a week or two ago. And if you don't remember what Phoenix MacroComponents is, it's okay because it's not out yet. And it's going to be delayed on top of that. So nothing to worry about quite yet. The idea behind MacroComponents is that there could be a processing phase of Heeks components, right? So Heeks is a compiled language. You put in a sigil of HTML-looking things with some sprinkles of Heeksy syntax in there. Heeksy.
Yeah, I like that.
And that Heeks syntax is then processed, right, and turned into functions of is split into static and dynamic pieces. All this is about Phoenix LiveView to get things out, in a very efficient manner over WebSockets. That's the whole point. And that AST isn't really exposed, to us just normal web developers, right? And so MacroComponents is the idea that you would have a hook into that AST as it's being compiled. I believe it's being compiled. Stefan of the Phoenix team had kind of talked about, hey, it could be really cool to do this. And it's kind of an implementation detail of how they're going to achieve the co-located JavaScript hooks that are part of a particular component, Phoenix component that you're writing, right? So you write your Phoenix component, it has a JavaScript hook in it, and then you put your JavaScript hook right there kind of next to the Heeks component. So that's the co-located part of that. And that needed some compile time, trickery to make that work. And so that API was like, well, hey, it's working for this. Why don't we just make that public? And he also showed off like another idea. It's like, well, with MacroComponents, you can take the internals here and convert it to like parse the body of a tag into Markdown, right? So you can kind of do whatever you want, really. So anyway, that's a lot of setup. That's what Phoenix MacroComponents is in a nutshell. In a simplified way, I'm sure I got something wrong there, but that public API part of that was planned to go in, Phoenix, the next patch of Phoenix, or minor release of Phoenix, but that's being delayed, and that's being delayed because, well, they're just still looking for a better API here that could be even more powerful than before. They don't say much more than that. Maybe LiveView 1.2 is where that's going to land, the macro component thing. So we'll see. 1.1 isn't out quite yet at the time of recording. So don't go chasing that private macro component waterfalls. Please stick to the public API that you're used to. I know that you're going to have it your way or nothing at all, but they think that you would be moving too fast if you did that. So don't do that. If you want to stay in tune with what work is happening there is a draft PR that's got the next crack at it. So you can follow that PR if you want to. I'm very curious to see where this goes because this could be very, very cool. It does involve macros, though, so you got to be kind of comfortable with macros, which is not normal. We'll see.
Did you know that downtime costs $427 per minute on average for small businesses and up to $9,000 per minute for medium-sized businesses? That's every single minute. Honeybadger helps you avoid costly downtime and saves you money by combining error tracking, performance monitoring, uptime monitoring, and more into one easy-to-use platform, helping you fix outages faster than ever. Best of all, Honeybadger is free to get started, and setup takes as little as 5 minutes. Be sure to bookmark honeybadger.io. That's honeybadger.io. And thank you, Honeybadger, for sponsoring this episode. And next up, we saw some interesting news from Supabase. So Supabase, if you remember, we've talked about them in the past. They are an Elixir company. They're using Phoenix and everything, PubSub and everything behind the scenes, but they are serving the JavaScript community, right? That's who they're serving. They're basically like Phoenix as a service to JavaScript developers. Is kind of the way I like to think of Supabase. But they have been growing in success. And one of the things they've announced is a new project called Multigres. And the reason we care about this is because it's about Postgres. And since we are using Postgres in most Phoenix applications, this is important for us. So to understand really what this blog post announcement is all about, we first need to understand something called Vitess. I'm not sure I'm pronouncing that right, but Vitess is a database clustering system for scaling MySQL, not Postgres, MySQL. And Vitess added sharding, connection pooling, query routing, resiliency and failover, and cloud native orchestration for Kubernetes. And Sugu is the name of the author of Vitess, and he built it at YouTube. So this was meant for scale, right? So what is Multigres? Multigres is a new proxy that sits in front of your Postgres database. It shares the same goal as Vitess, but it will be focused on Postgres instead. And part of the Supabase announcement is sharing that Sugu, the co-creator of Vitess, has joined the Supabase team, and he is joining Supabase to build Multigres, which is like Vitess for Postgres. That's all it takes to understand what is this talking about. Like the blog post is Vitess for Postgres. Like that means nothing. So this was like the scaling level that was applied to MySQL, taking that same focus and same co-author and co-creator of the tool that did it to Postgres. So the software isn't really ready to go today. But since most Phoenix applications use Postgres, this becomes a very interesting project to keep an eye on. It may enable Postgres to reach petabyte scale clusters in the future, which is their stated goal, is to be able to scale perfectly well from the single system setup all the way scaled up to petabyte systems and clusters. It's open source too. We've got a link to where the GitHub project is, though there's not much there right now. But it's listed as being an Apache 2 license, I believe, as well. So that's really cool. I mean, anything that's going to make Postgres scale even better, since that's my database of choice, I think it's awesome.
I was looking at this and I was thinking, how is this different from PG Bouncer? Because I think Supabase also does, things for PG Bouncer as well. PG Bouncer is a connection pooler for Postgres. I'm still remembering back in older days with Ecto, right? Ecto didn't really support the PG Bouncer, a connection pooler on top of it. Ecto also does connection pooling. Those are old days, though. That's gone. So PG Bouncer does work well with Ecto nowadays. But just to make it a little bit clearer, in case you're wondering too, PG Bouncer is a connection pooler, but it's not really about sharding or failover or things like that. That's where Multigres comes into play. So it's pretty interesting. I can't remember. I really want to say there is a MySQL. Microsoft bought a MySQL version of this. I can't remember. It's not Vitess or however you say this. There's other platforms like this, I think, that want to do this, abstraction layer for sharding things with MySQL. I can't. It's on the tip of my tongue. I can't remember the name of it, and I guess it doesn't matter. Multigres is pretty nice, and it's here. Well, it's coming, I guess, for Postgres. Very cool to see that Supabase, is supporting that as well. I figure it's very relevant to their business.
Yeah.
All right. Next up, there's a couple of MCP servers out there. What's MCP? Stands for Model Context Provider, and it's all the rage right now. Cue Zoolander memes here. It's all the rage. It's so hot right now. MCP servers, what are they? If I could summarize it in my words, you've got several web technologies that end up facing a thing, right? You've got HTML, which face people. You've got APIs like JSON and a variety of them like GraphQL that face machines, developers, really. I guess that ends up being people too, but it's more of an automated thing.
I think it's front ends and other back ends calling out to APIs. Yeah.
Yeah. And then there's going to be MCPs. MCP APIs, really. I mean, it's a protocol that sits on top of the other protocols. It's nothing too novel here. It's just a specification of how to do a thing, right? The difference with MCP servers, though, is that they are designed for AI clients and LLM systems, right? It's like you're building an API not for some other developer, but for some phantom of a person. The LLM, right? This is an automated thing. It's kind of like they just decide when to use the things in your MCP server, the things being tools, or you can define prompts for it. You can define resources for it to look and access and things like that. So that's part of the MCP spec. There's purposes wrapping around these entities that LLMs will then programmatically ask for and execute, right? So if you think in the older days of like AI things, you would have a lot of trouble just getting like structured JSON out of it. So you'd have to like really chain a bunch of prompts together to get it to give you valid JSON. Those old days are kind of gone, right? So these LLMs are now much more capable and structured to return JSON now. So that's good. But function calling is still a thing that it needed some help with to just really like perform an action. There's a lot of structure around that, right? That's why APIs exist. And that's where MCP is really trying to fill the gap here. MCP is a protocol for all of these LLM APIs, really. I don't think it's necessarily the model itself, but the way that we, I think, colloquially think of them now. Now we say it's Claude, Sonnet 4, Opus 4, or OpenAI 04, ChatGPT 04, those things. But those are models in themselves, but they're fronted by these APIs that everyone calls, right? Or applications, right? Claude Code is using Claude APIs to go access that LLM. That LLM is not physically on your computer. It's in the cloud, right? And so these MCP servers are for those LLM providers to call to get structured content about whatever the person configures that conversation to have access to. There seems to be an MCP server coming out every 6 hours, right? Like it's JavaScript frameworks all over again, like 4 years ago. And so there's several of them out there. Like there's a GitHub has their own MCP server that kind of interfaces with the GitHub CLI on your computer. MCP servers for just doing things like sequential thinking. There's MCP servers for accessing your Git repositories to just do things well, right? Okay, so that's what MCP is and how it is in the world at this point. Now, how can you, as an Elixir developer, provide one of these MCP servers? That's what I'm gonna talk about. So there's a lot of MCP server frameworks out there now in the Phoenix and the Plug ecosystems.
And this is a recent addition, right? Like this is like just popped up.
Yeah. And there's a lot of options. Wow, surprisingly, right? All of this is in rapid development, so expect breaking changes, right? But the point is that the ecosystem does have, as of this moment, a lot of pretty well-baked solutions. So that's the good part. I'm gonna be selfish because I'm here. I'm gonna talk about mine first. So I wrote one.
You built one?
I wrote one. Yeah, I wrote one. It's called Phantom. I feel like there's Phoenix, PH, right? Phoenix, and then Phantom. So you've got a lot of phantoms that are kind of calling your servers here. I think that's why it's named the way it is. In the show notes, we'll have links to all these so you can evaluate what's best for you. At the end of the day, these are all actually really good and fairly comprehensive solutions, so I don't think you're going to lose with any of them. But Phantom is definitely comprehensive. It includes almost all of the specifications of the MCP spec. At this very moment, it only supports streamable HTTP. What's streamable HTTP? It's just HTTP with SSE. I don't know why they don't just call it SSE. SSE is server-side events, right? Yeah. So it's one way, it's from the server back to the client, but the client has to open up that connection. And that still exists here in streamable HTTP. So it's still SSE. It's just that SSE is a little bit more rigid, I guess, on like where these kinds of endpoints are. But Phantom is something that you would plug into your existing Phoenix or your Plug router application, and you can make it distributed with the powers of Phoenix PubSub, right? So, like I said, nearly all of these have HTTP plug adapters. And the spec says that when a tool is being called or any of these entities are being called, it's going to be a post request to the server to get with some parameters that says do this thing. And then that post should do the thing and then return the results right then and there, right? It can also open up a GET request, and the GET request has no requests in there, right? It's just hey, open up a stream. That's all this is doing. Just open up a stream. I'm not expecting anything back. There's no action to perform. And that stream could be on, a different server. It just depends on the load balancer, however your deployment, strategy is. You could have 10 web-facing servers out there. So your GET could be on some different stream, some different node out there. And so if you have your Elixir nodes, Erlang nodes all clustered together, this is going to be important. So you need distributed capabilities on some of these things, because posts could then come in on these different connections to other nodes. They do their work, and that's fine. But those actions might emit logs or other notifications or things like that. And the MCP spec says that clients can subscribe to resources. So if they subscribe to resources, that means when that resource updates, you need to
be notified.
Yeah, I need to be notified. And that only happens over that open GET connection. So that's where distributed comes into play. Phantom supports, almost all of that. There's a light DSL to define all your prompts, all of your tools, and your resources. The resources are URIs, and so it uses like a plug router underneath the scenes to do the matching logic, right? So you build your template like you do in plug router, right? A get to this path, and then this part of the path is an ID, so that's a path parameter at that point. And by the time that you get it in your handlers, it's all what you would expect, right? It's just like a Phoenix controller at this point, right? Or a Phoenix live view with an event. And because this can be synchronous or asynchronous, it kind of adopts that no reply kind of gen server behavior. So you can stream results back over the connection when it's still open. Okay, that's a lot about Phantom. And so that's the basis. Let me talk about some more. There's also Hermes or Hermes, however you say that.
I would say Hermes, yeah.
Hermes, okay.
HermesMCP.
HermesMCP. It's also very comprehensive. It includes an MCP client in case you need to consume information from another one. When I first looked at Hermes, it was only a client, and then I developed Phantom, and then I looked back at Hermes, and then now they have a server too. But rapid development, like I said. They also include a standard in and out adapter. So if you need one of those, Hermes is a good option to look at. They also include a plug adapter. At the moment that I looked at it, they use the Elixir registry for matching up those get and posts, to understanding what's involved with the session. And the Elixir registry, by the way, is not node aware. It's local node only, so that's not going to work out so well in a distributed environment. I'm sure that'll be fixed eventually. So that's Hermes. Very comprehensive. It's a wonderful API as well. All of these are going to have a slightly different flavor, but it's all to the same spec, so it should look very similar. Another one is ExMCP, wonderfully creative name. It also includes a client and a server. They also have a standard in and out adapter and a plug adapter. They use Horde to handle the distribution strategy there. So if you're using Horde already, ExMCP might be a good option for you. So there's Phantom, Hermes, and XCP. All three of these, they aim to support the full spec of MCP. ExMCP is wonderfully documented at this point. Phantom will get there soon. Like I said, all this is rapid. And Hermes is also very well documented. They all have very similar APIs, but there's more or less macros or DSLs to get you set up in an easy way. Phantom is Phoenix inspired. ExMCP is very inspired by like you would use a tool, one of their modules, and then you have callbacks that you have to implement. Hermes is about the same way. Okay, so those are the comprehensive options. But if you need something simple, because all of those are going to come with dependencies, though I do believe that Phantom is fairly light in what it needs. Vancouver is another option. Vancouver is very simple. It only supports tools at the time of recording here. It's very easy. If you just have tools, which is probably like the first step for a lot of these MCP solutions that people are going to need, you're probably just going to need a tool for the most part. Their documentation shows very clearly it's very easy to just like plug in Vancouver. It's very lightweight. Plug in Vancouver and follow its APIs, implement its callbacks to implement your tools. Another option out there, last option, is Excom. Excom is written by Matt Trudell of Bandit fame. It's also very simple, a little light on documentation right now. Also only at the time of recording of what's published, only supports tools at the moment as well. But we've got lots of options coming up. So I developed Phantom without looking at Hermes or ExMCP. I didn't even know they were there. I guess I should have. Or I knew Hermes was, but only the client. I didn't know about ExMCP, though. I guess I should have found it pretty quickly with names like that. I'll just repeat. They're all great options. I'm not gonna tell you need to use Phantom. I'm just one library author out there among many, and Hermes and ExMCP are probably much more complete at this very moment, and Phantom will get there as well. Last thing about MCPs, while it's not a server on its own, Ash AI also has incredible introspection capabilities and is seeking to plug into all of those or any of those above frameworks. And so, yeah, you declare all your resources. Ash AI has MCP capabilities now. And if you are curious about that, there is a demo video. And so we got a link out to that video so you can really see the capabilities of what MCP can do. And then with all your stuff already defined in Ash, boom, you already have an MCP server, really. You just need to serve it. So yeah, anyway, so I hope you enjoy this little roundup session of MCP servers out there. There's a lot. And yeah, it's still rapidly developing, so don't stay too still, because it'll be very mature in probably just a couple of weeks.
It's the Cambrian explosion of biology and evolution, where it's just a whole bunch of stuff, and then at some point it'll whittle down to the ones that have the most traction.
Yep.
All right, next up, there's a blog post put out by a company that compared 7 languages and runtimes under extreme load, and they were kind enough to share their methodology and results. So I've got a link to it, but just wanted to highlight some of the things that they shared and learned from this. It's titled, "We tested 7 languages under extreme load and only 1 didn't crash. It wasn't what we expected." So they described their environment for the setup. They said, "Our testing environment consisted of a cluster of 16 high-performance servers, each running dual AMD blah, blah, blah processors with 192 cores, 768 gigabytes of RAM." So these are big machines, okay? And what they were really testing was concurrent connection handling, managing up to 1 million simultaneous connections, memory pressure, processing data structures requiring near total system memory, so really like large data, CPU saturation, performing complex calculations across all available cores, I/O bombardment, which is handling thousands of simultaneous file and network operations, error cascade simulation, recovering from deliberately induced partial system failures. So what they tested was Go, Rust, C++, Java, Python, Node.js, and Erlang. That's right, Erlang. When I saw that, I was like, oh, why not Elixir? Did they just not know? Did they not know? Nothing against Erlang, obviously, but anyway, I thought that was a missed opportunity. But what they said is, because really to give it a fair shake, right? And I really appreciate that they did this, is I said each implementation was optimized by engineers with at least 5 years of experience in that respective language and using the stable versions as of May 2025. So you can see the whole list of what they used, like all the details about the C++ options and which versions of Java and everything like that. And it was OTP 27 with Erlang. As it likely won't surprise many of us, it surprised them that the winner was Erlang. And they share more of the details on how each language performed, how they reacted, and where they would kind of fall down. And there were some just really fun points in the article I just wanted to call out. Like with Erlang, they described it as Erlang wasn't the fastest in any single category, but demonstrated remarkable resilience across all test scenarios. Its let it crash philosophy, combined with the supervision tree pattern, allowed it to recover from failure conditions that crippled other languages. And some of their key insights is that, I'm just going to read the headlines here. You can definitely go read for more detail, but architecture trumps raw performance. Memory management is the ultimate bottleneck, and concurrency models matter more than we thought. And recovery capabilities are undervalued. They go into some practical thoughts and analysis, and the conclusion, their takeaway was, don't go and just mean everything should be rewritten in Erlang. Elixir.
Erlang's fine. Erlang's fine. That's good.
I know. But when I think of like they're talking about like all these modern languages like Go, right? And Rust. These are very modern languages. And using Elixir with a modern dev tooling, modern language syntax, all those things, that would just make more sense.
Yeah.
Anyway, I thought it was a great little fun read. It's fun for us because, we were like, yay, I'm glad you discovered what we already knew. Maybe they're just validating my bias already, but I loved it. I really do appreciate them sharing all of that. Just like, here's all our methodology, here's the details. And they really weren't bashing on anything, because I think they were genuinely trying to figure out, we have some big system we want to create. How should we do that? So one of their very practical ideas was maybe certain key pieces of your architecture should be written in Erlang, was their determination. And just when you think about the performance characteristics that you need to have.
Yeah. I'm reminded of, I wonder if it needs to be updated, but I'm reminded of the classic Phoenix. It's probably I could probably find it real quick, but the classic Phoenix like use case, muscle flex kind of blog post of Phoenix can handle like, what was it? 2 million sockets, on a single server or something like that. Yeah. Like that's That's essentially what this was, right? Very cool. All right, moving on. Next one. A new LiveDebugger release is being teased. So at the time of recording, it's not out. Maybe it'll be out by the time it lands. Just a reminder of what LiveDebugger is. It's a package by Software Mansion that is a collection of tools for inspecting your live views in live time, in real time. The last previous... Sorry, I say previous. It's the current one at the time of recording. 0.2 includes a Chrome extension that is able to plug into your running backend app that allows you to kind of have like a React style inspector of all of your Phoenix live view components out there. You can inspect what live processes are running. It's things like that. If you don't love Chrome extensions, they also have like a different little page you can open up and it'll, kind of be the same kind of deal. So what is coming up in 0.3? Software Mention shared that a Firefox extension is coming up. Can't leave Firefox behind. Global callback traces is coming in to the next version. Callback execution time metrics is also coming. And enhanced redirect debugging. Oh, redirects. Bane of my existence sometimes. Yeah,
so
very, very hard to debug. It's like I'm very used to just debugging like one request, but when you've got 3 of them kind of chained together, it's like, why did I go from here to there? Very nice to see all of that coming into hopefully the next version of LiveDebugger. So yeah, we got a link to the social media posts that they talked about. So maybe they'll follow up on there, or just stay tuned for 0.3 whenever it's published.
And last up, just sharing that I was a guest on the Elixir Wizards podcast, where I talked about my Elixir LangChain project. It's the library that I wrote to make it easier for Elixir applications to integrate with LLMs. And this was started before MCP servers existed. And I am thinking about how I can leverage MCP servers, assuming you already have one. How can we make that work with this? So anyway, I talk in much greater depth about what the library is, how it works, and what problems it helps solve over the very common roll your own option and why you might want to consider using this library. Had a great time talking with them. You should check it out. Well, that's all the time we have for today. Thank you for listening. We hope you'll join us next time on Thinking Elixir.